Hey guys, it's Mrs. Turnbull with your Tuesday video. There was an error in the previous version of this video, and so I'm just going to redo it so we can get that error out of here. We are talking about trigonometry in these next series of videos. Specifically in this video, though, we're going to deal with Pythagorean theorem. By the end of all of these videos, you will be able to explain the relationships between similar right triangles and the definitions of primary trigonometric ratios. You'll be able to identify the hypotenuse of a right triangle and the opposite and adjacent sides for a given acute angle in a triangle. You'll be able to solve right triangles. You'll be able to solve a problem that involves one or more right triangles by applying the trigonometric ratios or the Pythagorean theorem. And you'll be able to solve a problem that involves indirect and direct measurement using the trigonometric ratios, the Pythagorean theorem, and measurement instruments such as a clinometer or a meter stick. Now, when we're talking about Pythagorean theorem, we have one formula, and it's right here. A squared plus B squared equals C squared. Now, when we're talking about a right angle triangle, it looks like this one right here. It has a right angle and two acute angles. The right angle is always marked by this little square, and a right angle, just in case you've forgotten, is 90 degrees. There are no other angles that qualify as a right angle. A right angle is 90 degrees. And the most important variable for you to know which one is which is this guy right here, C. C is called the hypotenuse. Okay, it's right here. And the hypotenuse is easy to find in a triangle because the right angle points at it. Okay, so it's always across from the right angle. A and B are the other two sides, and they are interchangeable. It doesn't matter whether you decide this one's A and this one's B, or you decide I want this one to be B and this one to be A. It does not matter. All right, let's get into some practice questions here, some examples that help us figure out what's going on. So again, our formula, A squared plus B squared equals C squared. I'm going to decide this one's going to be A and this one's going to be B for this. So 12 squared plus 9 squared equals C squared. That'll be 144 plus 81 is C squared. Let's pull our calculator up. We've got 144 plus 81 gives not times 81, 144 plus 81, and then we're going to square root this. Now, we've been using the scientific version of this calculator up until this point, but it's important to know that if you're using a Microsoft calculator, you need to go back to the standard type of calculator that's in this menu here. Go back to the standard so that you have a square root button. The scientific calculator, for whatever reason, does not have one. So we'll just use this here, and that tells us that C is 15. So C here equals 15. Why do we have to square root this? Because this answer, 144 plus 81, is C squared. So when we got our previous answer of 225, 225 is what C squared is. Okay, so C squared equaled 225. We have to square root both of those in order to get our value for C. Okay, let's do another example here. A squared plus B squared equals C squared. These are the simple versions where we're solving for the hypotenuse. All right, I'm going to call 10A and 24B. So 10 squared plus 24 squared equals C squared. C squared equals, let's put this into our calculator here. So 24 squared is 576. 10 squared is 100, so we'll add 100 to it. And then we're going to square root it. So 676 goes here. Now when we square root it, what we get is 26. So C equals 26. Okay, last example here. I'm going to say this is A, this is B. A squared plus B squared equals C squared. 7 squared plus 3 squared equals C squared. 7 squared is 49 plus 9 is C squared. That'll be 58. And when we go to the square root of 58, we get 7.62. Okay, so these are simple versions where we can use the formula the way that it's existed the whole time. There are also questions that you're going to have to figure out where you're looking for a different side, okay? A side that is not the hypotenuse, because this one is the hypotenuse here. Again, the right angle points to the side that is the hypotenuse. Okay, so again, the original formula was a squared plus b squared equals c squared. We need to move one of these over to the other side in order to be able to solve for one of the other sides. I like to just assume all missing sides that aren't the hypotenuse are a squared, which means I need to get b squared over to the other side. B squared is attached to a squared with addition, so we have to subtract it to move it. So we get a squared equals c squared minus b squared. Okay, so let's use that formula. A squared equals c squared minus b squared, where this is c and the other side we have is b. Okay, so a squared equals 10 squared minus 6 squared. So this is going to be 100 minus 36, which is going to be 64. And then we've got to square root that, which gives us our answer of 8. Okay, one more time. A squared equals c squared minus b squared. A squared equals 24 squared minus 6 squared. 24 squared is 576. We have to subtract 36, which is 6 squared, and we get 540. And then we have to square root that. We get 23.24. Okay, one last example. This is a word problem. There's a second word problem in the notes for you to practice. When we're dealing with word problems, we have to draw a picture, label the sides that we know, and then we're going to solve the problem. So I usually just like to draw a right angle triangle before I even look at the question. It does not need to be clean, can be a really rough sketch, doesn't matter. So we've got a ladder, it's leaning against the side of a 10-meter house. The house is 10 meters tall, so I'm going to put that on this side. If the base of the ladder is 3 meters away from the house, that's this side here. How tall is the ladder? So we're looking for the hypotenuse here. Again, the right angle points at the hypotenuse. So we can use a squared plus b squared equals c squared. All right, I'm going to call this one a, this one b. So 10 squared plus 3 squared equals c squared. That's 100 plus 9. So 109 c squared. We've got to square root that. We get 10.44. Our units are meters. Now this is a word problem, which means it requires a word answer. So the ladder is 10.44 meters tall. Okay, so Pythagoras is not supposed to be super confusing. If you have any questions about that, make sure that you send your teacher an email, book an appointment to meet with them over Google Meet or whatever service your teacher uses. Don't forget that it's really important to get help when you need it in math. Don't allow yourself to get super frustrated and just shut down. Okay, so get help when you need it, and then we can help you through each concept and get you moving on your way to the next one. I hope you found this video helpful, and we'll see you on Thursday for the next one.